project overview, which is kimchi. It is a traditional Korean dish created by fermenting vegetable, which is gained popularity throughout the world due to its nutritional, helpful, and organoleptic qualities. The formation of different LAB or lactic acid bacteria is caused by spontaneous kimchi fermentation in unsterilized raw materials. Kimchi undergoes fermentation by anaerobic halophilic lactic acid bacteria, which leads to variances in taste, sensory aspect of kimchi product, as well as challenges in standardized industrial production of kimchi. Background history: for centuries, fermented vegetable, known as kimchi, has been an essential part of Korean cuisine. The initial purpose for kimchi invention is for food preservation. Now it is regarded as a healthful cuisine and a sign of identity for the Korean people. The process of making kimchi involves fermenting vegetable along with other ingredients, which is seasonings, in a closed container, ideally at a low temperature to promote long-term preservation and moderate microbial activity and flavor development. The LAB causes the fermentation of kimchi, resulting in the production of many organic acids and other chemicals that give kimchi its distinct and unique flavor. Next, for general, the fermentation of kimchi involves a variety of bacteria. However, during the sorting and fermentation stages, LAB take over and the harmful bacteria are suppressed. The incorporation of additional sub-ingredients and the production of LAB fermentation byproducts enhance the LAB fermentation process, which in turn eliminates the harmful and pathogenic bacteria. For example, Lactobacillus, Leuconostoc, and Pediococcus are LAB present in the kimchi. The fermentation procedure also improves the functionality of kimchi, where it can be viewed as a vegetable probiotic food that offers health advantages compared to yogurt and dairy probiotic food.
So I will continue for the kimchi production flow diagram. In this diagram, each colors under process flow and controls are matched. Green indicates both process, blue indicates vegetable process, and yellow indicates cabbage process. In the flow diagram, CP means control point and CPP means critical control point. Next, the first section of the flow diagram is cabbage process. First step is that the cabbage received will be inspected and stored at temperature lower than 10 degrees Celsius. Second step, we will trim and remove outer leaf. Third step is we will cut the cabbage received into small pieces. Fourth step, it has CP point, which it needs to rinse. Portable water is used. Rinse the free-flowing water or change water every 2 hours. Fifth step is brine. It has CCP point. First, brine concentration must be lower than 5%. Brine must not be reused. Salt concentration range from 5 to 15%. Average is 10%. Sixth step is hold for several hours. The cabbage will be whole for several hours. And last step for first section is a CP point, which need to check. Rinse for the second time with potable water and rinse with free flowing water 2 times or change water every 2 hours. Some salt is used off during second rinse. I will continue for the second section, which is vegetable process. First step is vegetable and rice sauce ingredients are received. Second step, it has CP point, where blender blades will be used to puree and commercial dicer may result in metal fragment. It is need to check blades visually or with metal detector. Um, we will do puree garlic, onion and ginger in blender for sauce, and cut carrot and radish with commercial dicer. Third step is hold in toads at room temperature. And lastly, fourth step for this section, we will make rice sauce, heat and stir until smooth. Cut vegetables and sauce ingredient, including fermented fish, salt, sugar and rice flour, are low risk and can be held at room temperature. So rice sauce adds more salt and continuous brining process. The final concentration of salt must be between 1.6 to 1.8%. So this is the last section of the flow diagram, which is the mix with cabbage and vegetable and sauces. First step is that we need to mix cabbage, vegetables and sauce into toads. Brining continues with sauce condition and need to cover. The cover is to ensure all cabbage and vegetables are protected from contamination. Second step is ferment until pH reach higher than 4.6. Kimchi pH higher than 4.6, observe formation of bubbles and monitor pH every 12 hours until pH drops to 4.6 or less. pH is lesser than 4.6 before packaging and refrigeration. Third step is refrigerate to less than 4 degrees Celsius. Fourth step is weigh and package kimchi into sanitized jar. Fifth step is pack jars and make up pellets in cooler, which will store in lower than 4 degrees Celsius. Lastly, the product will be shipped under refrigeration lower than 4 degrees Celsius. The fermentation option and critical limits. There will be two options. First option, ferment for 2 days at room temperature. B option, ferment at 4 days but at lower than 10 degrees Celsius. This is to prevent growth of pathogen. Initial ferment should be begin with 48 hours.
Hi, my name is Nazir Shazwan Gunusli. So for this project, I will presenting about type of bioreactor. So in this current industrial production of kimchi, traditional fermentation containers such large baths and jars are predominantly used rather than sophisticated bioreactor. So basically, there are no any type of bioreactor that used in production of kimchi. So basically, in fermentation process, there are 3 steps. First was packaging. In the packaging, the seasonal vegetables are packaged into fermentation container. This container can range from the large vats into individual jars depending on the scale of the production. Next was fermentation condition. The container are stored in a controlled environment where temperature and humidity are regulated. Typically, kimchi ferment at a lower temperature such 4 to 20 degrees Celsius to ensure the growth of a lactic acid bacteria and the development of desired flavor. So last one was duration. Fermentation can vary from a few days to the several weeks depending on the recipe and desired flavor profile. That's all for me. I will pass to next presenter.
My name is Zul. Now I will tell about the optimization of fermentation parameters. First is temperature control. The optimal refrigeration of temperature range of -1 degree Celsius to 7 degree Celsius for kimchi fermentation. Second is pH control. It is around 3.8 to maintain the desired microbial environment and prevent contamination. Third is nutrient composition. It is optimize the sugar and salt concentration to 5% and 2% respectively for optimal fermentation and product quality. Next, I will tell about the improvement on the technology. First is 3D printed bioreactor. It is to create customized bioreactor components such as impeller and mixing chamber, tailored to specific research or production need. Second is advanced sensor. Advanced sensor is such as optical device for measuring pH and dissolved oxygen, and gel-filled miniature pH sensor and oxygen sensor are being developed for non-invasive monitoring and control. Next improvement on the technology is about computational fluid dynamic CFD simulation. It is identifying and addressing suboptimal conditions such as mixing, efficiency and oxygenation without interrupting ongoing operation. Next is inline monitoring and control. It is control parameter like biomass, metabolic level and protein titer. It also adjusts condition based on this data to optimize production and efficiency.
Okay, so now I will continue the presentation to the safety and regulation for kimchi production. The first one is HACCP, stand for Hazard Analysis and Critical Control Points, which is it approach to identify and to control the hazard throughout the production. So it is important for kimchi production as it identify a lot of things from the production, as it for the safety, the raw materials used and everything. So the part that has been used for the critical control points is the salting and or braining parts, the process. And then the second one is the fermentation temperature, also the final pH for the kimchi production process. So it is implemented to the food safety, as it will helps in identify if there is any problems for the batch product. Okay, so the second one is CGMP, stand for Current Good Manufacturing Practice. So it is a guideline for the quality and safety for production, especially for kimchi production. It is used to identify the specific part, which is the facilities, the equipment, the process, the SOP things inside the fermentation process. So CGMP emphasize the hygiene and sanitizations, and also it's record the keeping for safe productions of fermentation. So the third one is the FSME, stand for Food Safety Modernizations Act. It's applied in United States. This is the regulations for to control the food supply chain, as it is similar to the CGMP and the HACCP, but this one is used for almost every country for kimchi production. And as kimchi is produced in Korea, so there are another regulations in HACCP, which is Korean Ministry of Food and Drug Safety. So it is used to identify a lot of things in the kimchi production process. So the regulation used for food production
which is the first one is the Food Act 1983. It is used to governing the food safety of every processed food or every fermented food or every food that has been produced to the market, and it prohibits the sales of unsafe food. So if the kimchi productions have some chemicals, hazardous things inside, so it's gonna be taken an actions under the Food Act 1983. So the second one is the Food Regulations 1985. So this one is the regulations for with three things inside it, which is the chemical safety, the biological safety, and also the physical safety. So for the chemical safety, basically it's about the chemicals, the harmful chemicals used in the food productions of kimchi. So if there is leads or metals used, or it is exposed to the chemicals, so it's going to be taken under this act. So chemical safety is used to identify the hazardous chemicals. So the second one is the biological safety. If for every fermentation food there are biological microorganisms and everything, but if there are microorganisms that is bad for the productions and for the products, so it's also going to be taken actions on these Food Regulations 1985. So the third one is the physical safety. So the physical safety ensure that the absence of foreign object or harmful physical contaminations it can be seen clearly as its physicals outside, and there are a lot of regulations used for fermentation for the kimchi process, but however we would like to highlight these two as it is the most used in Malaysia, and it is suitable for every country to regulate the acts of it. Okay, I think that's all from me. Thank you.